Hello and welcome to the stream. So today I'll be attempting to write a basic kind of skeleton programming language, more or less from scratch. I'll be using a parser generator called LALRPOP, and yeah, I suppose I'm just really going to get stuck right in. First thing I do want to mention first, I've pulled a so I'm new to Twitch, so some of the configuration that you might see here, I've pulled pretty brazenly from I think it's NoOpCat. Uh, has a Medium post about their coding setup, which yeah, being new to this, I just kind of used a few, say, of the suggested scenes, including scrolling text and things. So I just wanted to give a quick shout out in the chat to them and uh, link the article. Um, and yeah, with that, yeah, I suppose I'm just going to get stuck in. Now, I do have some basics setup already done, so I'll run through that quickly. So here's my coding environment. I'm using Vim. I have a few scripts in here. So these are kind of Docker utility scripts that I add to my projects to help me get up and running. So these will help me just run my command. So for example, this project is going to be using Rust, but I don't install languages on my system locally. I install them in Docker and then run commands on my local environment through Docker. So these are just scripts um, that I use to get it set up with that. You'll see examples of this running in a minute. Um, and there's also, I'll actually just post a link to, let's see, this chat box. So I'm using OBS for streaming, and this new to this chat box and a little tricky to use. So here's just a quick link to my blog where I explain those scripts in a bit more detail. I won't be going through that here. I have a little to-do list, which I'll probably be referencing during the course of this call. I've a little README just to initialize the repo and license file, and I have a blank cargo file, and finally we'll start off with this build.docker file. So this is the environment that I'm going to be running everything in, and this is what these Docker build and with build-env are going to be running relative to. So where to start? I suppose, yeah, so I've a few crib sheets here, so I'll be glancing at those from time to time. So I'm going to start with my main.rust file. So let's see here. So what do I need first? So let's get started and just get up and running with a regular hello world. So print line. Oh wait, we don't have to do that. I don't think. Oh no. Yeah. Hello world. And save that. So first things first is to get the environment up and running. So like I said, I use this script called with build-env. And the idea with these for me generally is that I have an interactive and a non-interactive version. So this is actually, this build script just has an interactive version. So basically, when I run the script, it'll give me a bash shell or just a regular shell in the build environment with my project bind mounted. So basically all that means is if I go click find in here, we'll see all the files that I have in my project. And also if I do a cargo build, for example, oh yeah, my cargo.toml is empty as well. So let's go ahead and populate a bit of that. So we'll go package name. So the provisional name for this project is just Skeleline. For skeleton language, I'll be using it for kind of language design later on. Name is just a placeholder, really. I'll probably be modifying this after the stream ends. But when we go cargo build, yeah, that's all built now. And if we go target debug and what's the name, scale lang, then we get our hello world. Perfect. So this is an example of what it looks like to run that to run the build in that shell. Now, what I'm going to be using for this particular project, because it can have kind of quite a tight development loop, I'm going to just set up this this tool called ENTR, which I'll be using to basically, whenever a file changes in the source directory, I will just kick off a build and execution of the program. So let's take a look here at what would be involved in that. So first of all, I'm going to take a look at the Docker containers that are running here. And so the Docker container that my build environment is running in, so we can see skeleton build is running in Naughty Dubinsky. So we'll just try first of all, so docker exec ti. So we're just going to try first of all, try building and running the tool using a single command. So we're going to do a docker exec shell c, and we're going to do a cargo build, and then once the build is successful, we'll go target debug and scale lang. So let's see if that works. No such container sh, of course not. So the container name itself is Naughty Dubinsky. And yeah, so now we can build that in one line. So what we're going to do next is, in fact, yeah. So next thing I want to do is, so like I said, I'm going to be using ENTR that uses a list of files, and it basically listens for changes in those files. So I'll build this up interactively. So first I'm going to find the files that it's going to build. So that's just build source or find source, and gets all the files in there. I'm going to grep v the hidden files, so that they don't get sent to ENTR. So what's going wrong here? So is that, no, that's a start of the string. Find source grep. Okay, because it's not actually starting with dot, so it'll be source dot. Yeah, and then finally we go to ENTR. That's not going to work because it needs a command, and I think so. We'll run that first of all to just get that in the bash history. We're going to have C so that it clears the screen every time, and then finally we'll pull it all together. Yes. So basically, this will recompile the project and run it again every time we make a change. So let's see here. Yeah. So making a change and saving the file here will result in a recompilation over there. So now we have the environment up and running. I'm going to start with adding a few files. So again, I do have this crib sheet, so I'll just be kind of fleshing out the body of the project. And one thing to note about here as well is that funny thing about building up some of these, especially kind of projects where the syntax and semantics are fairly well understood with the language, is that once we kind of hit a critical mass of, say, building up the abstract syntax tree, so the kind of intermediate model of our program, and once we've a few of the basic features implemented, we'll get to a point where a lot of these features will kind of write themselves, but we do need to put the kind of scaffolding in place to get to that point first. So where do we start? So first of all, let's try, yeah, so we'll just add, to make things easier on ourselves, we'll add a basic mechanism for reading a test file and rendering it. So let's see. So to start off with, we're going to define find test.txt, and the first snippet. So I wrote a quick snippet on dev.to with some sample programs I'd be writing in this language. So I'm just taking the first of these, and this is going to be the features used in this is going to be our first kind of list of to do things. So there's a few things happening here. We've a variable assignment, we have an if statement, we also have an else block on that branch. We've printing, we've string definition, and we've comparison with a variable. So there's actually, in terms of kind of programming language features and things, there's actually a fair bit going on there. But first thing we want to do is just get this set up so that we can easily read this file and process it. So to do that, let's see, I'll just, again, view my crib sheet, because Rust isn't my daily driver for programming. So I do sometimes need reminders on just, things about syntax, like opening, reading files and all those kind of basics. So let's go starting. So we're going to open source test for now, .txt. We'll unwrap that. So again, error handling here to start with isn't going to be our top priority, but we will be making that kind of a higher priority later on. First is to get it working, and then is to get it fast. So we'll read all the lines from here, and so I have a more advanced example in my notes, but I don't think we need this right now. So what I'll do is just a basic implementation of what I have in my notes, and that'll just get us up and running quickly. So we'll create test. That's going to be a string. Can I do that? Actually, I'm not sure. Again, fairly rusty with Rust, but I believe that's right. So all we're going to do here is, for every line in the file, we're going to just push it onto a new variable. I know there's going to be a shorter way of doing this, but I'll be refactoring later. So we'll go if there's still a line, then we'll append it onto here. Otherwise, we will break out of our infinite loop. And then finally, we'll return the test. Excuse me. And for our debugging, we will output the result of that. So let's see what we have here. So filter resolve. So we haven't actually imported that standard library item. So file. And do we need IO yet? We need buff read anyway. And buff reader. And we'll just make sure all of those are sorted. Expected a character but found a result. So we need to, yeah, so for now, again, not paying too much attention to error handling. This will just be in one wrap. Expect a character but found a string. So test push. Maybe, and no, maybe is a push string. So if we borrow that, does that work? Yes. Now that is outputting it as a debug output. And here it's output. Okay, so it consumes the new lines. Will we add them back in for the moment? We don't need to really, because for the moment our parser is going to be consuming them anyway. So now in the language that in the full language that I'm thinking of, which I'm researching, it's going to be for optimizing shell-based commands. So essentially trying to replace bash script in a lot of scenarios, and that will have, it will try to do a similar approach to Golang, where you know, we replace new line, or it has this kind of injection of semicolons instead of new lines at various places. So we're going to try and take that approach later on, but for the moment, we're just going to have semicolons ending statements. Actually, that reminds me of a typo that I made in the dev2 code, which is I left out semicolons in this snippet. So great. So we have our test case being added and read and rendered. So let's just put that in a variable first. So let test equal this, and put that there. And then the next thing we want to do is actually start integrating LALRPOP. I'm not even sure if that's how you pronounce it. That's how I'm going to pronounce it until proven otherwise. So let's see. So first we want to add the dependency to our package cargo.toml for Rust. So we'll have build dependencies, and that'll be LALRPOP 0.19.5 is the latest version. And then, yeah, I believe that's all we need for cargo.toml. Now, LALRPOP generates the parser as part of the Rust build, so we can actually create a new build.rs. And this will help us integrate the whole framework. So this will just find the LALRPOP parser that we're going to create in here. So parser.lalrpop. And so we're going to basically define our grammar in here. And LALRPOP is going to run in the build.rs and process that and generate our parser for us. So what's the simplest way we can get started here? I've done a little prep for this stream, but possibly not as much as I should have, but we should be all right. So let's see. So first of all, what we're going to do, we'll define our program. So, no, there are a few things I need to put in first, aren't there? So, will I put in the AST file now? Yeah, okay, we'll start off with the AST file first. Ooh. So, for those unfamiliar with AST, it's abstract syntax tree. So basically, once we process our actual source programming language file, generally we'll turn that into this kind of intermediate model for later processing, for easy processing, called an abstract syntax tree. So it's just a tree data structure that kind of contains the structure of our language in, like the name implies, in an abstract fashion, but it'll allow us to kind of walk and rewalk and visit different nodes, do different types of processing in different ways without having to reprocess the file as we do so. So it's basically just kind of a neat representation for a source file. So I'll empty the parser file for now, and I'll add ast.rust, and this is basically just going to contain all the different types of nodes that our AST will define. So it's going to start with so a program node, and each of these are going to derive, clone, and debug. Again, not necessarily best practice to kind of give blanket definitions to all these, but in the interest of just doing this quickly, I'll be adding these. So we'll say that bodies, the body is just empty for now. So we'll try and get this up and running first. So parser then will be defined as, let's see, so we'll just put the word grammar here. I'm not quite sure what it's for, probably just to, as a marker for this file, but I'm not positive. So again, I'm going to do a blanket import here. I usually wouldn't use star imports, but it'll just make things easier for now for the development part, and then we can lock down on the actual imports later. And then we'll say there's just one rule for now. It matches the program terminal, and well, I can't remember the meanings of terminals and non-terminals. It's been a while since I've been in college, but it's going to produce, basically this is what it's going to match, and this is what it's going to produce in terms of actual Rust types. So what will we put in here to match everything? For now, we'll probably just do that. I'm not sure if that'll even work, but I just want to get the parser running, and that'll produce a program body. And what else do we need or want here? So we have the parser up and running. The last thing is probably actually just invoke it now. Let's see, again, there's a bit of boilerplate that I don't necessarily know what it's doing at the moment. All I know is that I need to do it. But we're going to just add some stuff to do with LALRPOP. Util. Did I import the util? Does it need to be added to cargo? Can't remember. All I know is these are things that I must write. Let ast parser. We won't sweat the details for now. So whoops, keep mistyping. So program parser. So LALRPOP is very nice in that it actually gives you these fine-grained parsers. You don't for each terminal, so you don't actually have to always work from the root parser. So we'll create a new program parser. We'll parse the test data that we have, and again we'll just panic if there's an issue there. Excuse me. And for now, we'll just output the AST using its debug definition. So let's see what it looks like there. So it's installing LALRPOP. Oh dear, this could take a while, couldn't it? I probably should have set this part up a bit before the stream. Anyway, yeah, that's all right. It gives me time to figure out what next. So we've our main added, we've cargo added, we've build .rs added, added the parser, added the AST, and added our test file. So where to start with? So if we look at our test file that we're actually parsing, so first thing we want to do, would it make more sense to actually add support for comments first, so that we can just deal with these things as they come up? I think that would be a prudent course of action. Yes, I think that is what I will do. Once the thing is actually running. Yeah, I'm also not even sure if this is going to work. Now, I know in general regex doesn't match new lines, but I feel like this LALRPOP version will. So we're having an issue here with LALRPOP util, like I was thinking before. Ah, yes, that is an actual dependency in cargo toml, which makes sense that I wouldn't be downloading the same file twice. But anyway, so I'll quit out of this and I'll actually start it again, because we've added new files to the source directory that ENTR is going to want to keep track of. Nice, and we've a lot of errors now. So let's see. Yes, I am missing that crate and that import. Let's see what that looks like in my crib sheet. Again, not the most familiar with Rust syntax, especially around the imports. I like the idea of Rust imports, but I don't understand Rust imports. I have to reference it every time. So we expected a string there. And will that be good for us then? And we panicked on an invalid token. So yes, our blanket match of everything to produce a program didn't work, but we have you know, a working parser. I'm not quite sure what the parser does yet, but it does something. And so let's see. So to get us started off, we'll add some support for comments. So we're going to have an invalid token issue there. But we'll take care of that using some special magic. Now, this is just something that I got working recently with LALRPOP, and this is the ability of LALRPOP to. So in general, should I just call it the framework in future? I feel like I'm butchering the name. So the parser framework generates auto generates a lexer and a parser for you. Are those the terms? Again, it's been a while since I looked at compilers, but it automatically generates a lexer from you that, in general, if you want to modify it, you just have to write your own one from scratch. You either use it out of the box as is, or write your own from scratch. However, it seems like recently they have added, now I'm not sure how recent, but they have added support for modifying it slightly. So what I'm going to do here is this is going to allow us to skip lines starting from the pound symbol or hash symbol. Now, just looking at this here, it's not clear to me that this will properly identify a hash that's within a string, but we'll worry about that later. Again, this is just a toy language. We're not going to take it too seriously, but basically this is going to skip. So we can see here that we're not doing anything with. So when there's a match for this branch, we're not actually going to do anything with it. So basically these characters will be discarded. So it'll start with if we match a pound symbol, and then we match any number of characters that aren't a new line, and then we'll also match any number of new lines. I'm not quite sure why we match any number of new lines instead of just one new line, but there's the advice given in the manual. And this doesn't have a match mapping defined for it, so we also need to match all. So again, these are additional rules for the lexer, so and they override the default lexer, I believe. So once we override any part of the lexer, we kind of have to define what we want for all of these things. So we'll define what we want to do with comments, and then just say that use default actions for the rest of the lexer. So does that get us past this point? Yes, it does. So next issue is that we reached the end of the file unexpectedly. So what's wrong here? I'm not sure, but what we'll do is we'll start by defining a simple statement, which will be an expression. So just when we have the number 1, what should the parser do? So so a program will be built up of statements, and statements can be either evaluations that don't have an inherent value to them by default, such as an if statement, or it can have a value that's discarded, which is an expression. So that's where we're going to start. So this is going to be an expression, which is going to be an integer literal. So let's just go ahead and start building out the structure of this thing. So a program can be any number of statements, and that will produce a program body with statements, and then a statement. And again, this is going to be another isomin or AST. So when we match a statement, that can be just an expression followed by a semicolon. And in that case, we say that the statement is just an expression. And then what kind of expressions are we going to allow? So so to start off with, we'll say that an expression can just be an integer literal. So int literal. So the variable names I'm going to use in this, again, just for the interest of speed, they're going to go for conciseness or brevity rather than being very self-explanatory, and they're more going to be explained in the context of where they're written. So basically the variable names aren't going to be very good in the short term anyway. So last thing then to do is to define our int literal. So is this a terminal or a non-terminal? Again, can't remember the textbook definitions, but I kind of remember how to do this stuff, so it's all right. So here we're going to use a regular expression to say we match any number of characters if they're matching 0 to 9. And this is going to be the variable that represent. By the way, yeah, I haven't really been explaining LALRPOP as we go along, but on the left-hand side, anytime we match something, I'm using this syntax where the left-hand side of the match definition is the variable name is a variable name for the match that we can use on the right. So basically, if we match a regex with this format, that'll be stored in the variable s. We can then use, so that'll be a string with the match. We're going to parse that and unwrap it, and this is then going to, so this is a string, it's going to call parse on it. It's going to use Rust magic, so Rust knows that we're returning in int 64 here, so it's going to say parse it to an int. And again, don't worry about errors. So that's about it for our new terminals and such. Next thing we need to do here is actually add these variants to our AST so that we can actually represent them in the generated output. So what did we define above? We had an expression, and our programming body was a vector of statements. And a statement for now can just be an expression. An expression can be an int. And finally, yeah, that's all we need then, because yeah, that's self-referential. So that might be all we need. And let's see what errors we get here. And oh, we don't actually get errors here. So this is a fairly simple program, just defines the number 1, and we get our abstract syntax tree out. So there's our program's body, we have all our statements, and we only have one statement, which is an expression, and it's just an integer. Nice one. So next thing we probably want to handle is assignment. So let's see what happens at the moment if we run this. And of course, we're not even evaluating any of this so far. We're just we're just printing the AST. So should we evaluate it? Yeah, until we have functionality to print stuff, we're not really going to be able to observe the values, the evaluation of our program. So maybe that would be a good next step, actually. So just before we do assignment, we'll add support for printing. And so there are 2 things in here. First of all is function actually there's a lot going on here. First of all, there's a function definition. There's also definition of the project environment. So the definition of the print function has to exist somewhere. So so that when the program sees the word print, it knows where to look and where to find it. So that'll be defined in the environment. It'll be a built-in function, but it has to exist somewhere. And we have to be able to handle parameters which themselves have to be evaluated. But we'll get through all of these in time. So one thing, I'll leave one interesting bit till later. So next thing we want to do is so we'll add it to our AST first. Actually, I need water. but yeah, yeah, I'll get it now. Time to try out one of these new scenes, and I'll be back in 5 minutes. I just realized that the name of the stream is still test, I believe. Now, this is not the test stream, this is the actual stream. I hope I can change the name later. Anyway, let's get back to it. So next thing we want to do is support function calls. Now I feel like I'm skipping a step here, but anyway, we won't worry about it too much. So let's see. What did I do there? I pressed Z twice, I think. And let's get back to here. There we go. So next thing we want to do is support function calls. And what will a function call look like? So a function call will be an expression anyway. And so it'll consist of, first of all, let's see, a name, or we'll call that func. Yes, we'll call this func for now. And that'll be an expression or an identifier. No, it'll evaluate decisions. For now, does it need to be an identifier? No, we'll make an identifier for now, and then we'll add. So the toss-up here is whether to define support for first-class functions now or later. So if I define functions to be function calls to use just identifiers, that's not going to allow first-class functions, or at least not in the way that we're so used to them these days. But for the moment, we just do it like this for now. So let's do this incrementally. We'll just say you can have one hard-coded parameter, your arg, to the function, and the argument is an expression. So this is going to be the parser is going to recursively parse this, and when it returns it, it'll be a call, and yeah, we'll so the actual definition of the argument in the definition and evaluation of the argument isn't that tricky, but it's actually defining the parsing rules for it. Just don't want to get into it right now. So what I'll do is vec and just put create a vector of a single a single item, and so we haven't defined an identifier yet, so we'll use the typical kind of identifier rules. Again, we're just doing a lowest common denominator implementation here. So this will be, so it can start with a letter or an underscore. Ooh, very fancy. And then it can have any number of numbers and letters. And anything else there? No. So this will parse as a raw string, so we need to change it to a capital S string. Because Rust, and I don't fully know the string rules in Rust. So we don't have that variant yet. So we'll add it to expression. So function is going to be a string for now. And the args are going to be a vector of expressions, but these are going to have to be in a box. Again, something that I have tentative knowledge about, but I don't always know why I have to do it. I just know I have to do it to please Rust. And we have to put, because we're defining this to be in a box, we have to put it in a box. And yes, we have our stuff now. So now we have this whole thing going on. So we now have an AST parser, and we have something that can effectively print its own state. So now if we have side effects, which is what print gives us, we'll be able to observe the state of the program at various points. So that, at this point now it makes sense to actually evaluate the program. So let's go ahead and start evaluating. So we're basically going to have an eval function for each node in our abstract syntax tree. So this is, so even though our error handling in general isn't too great, do we want to just use panics everywhere? Probably no. I don't like adding in all the proper error handling later. So what we'll do is, so a result will be, so the evaluation of a program in this new language will be a value. So I'll create a new enum for that. Actually, I didn't check with this variable name before I wrote this. So I assume this isn't a reserved type or anything in Rust, but we'll see soon enough. So the evaluation of a program won't actually have a result. It won't have a value because it's a sequence of statements. And if something goes wrong, again, we're going to have very poor error handling here, but it's just going to return a string if anything went wrong. So evaluating a program will essentially be, so if we look at our AST again, so, oops, no, that's not good. So if I close that and that, and take a look at our AST. So, so basically evaluating a program will consist of evaluating all the statements in that program for now anyway. So for statement in, and we'll take, so we'll just do this shortcut because we only have one type in the body for now. Can I do this prog? Yeah, I probably can. And for statement in, whoops, for statement in statements, I'll close that actually and get back to my AST. For statement in statement, I'll evaluate the statement, and we're getting to that kind of critical mass. Well, no, we're not getting to that critical mass, but there does come to a point where you can kind of see how this is going to evolve, because a lot of the things, you know, you're going to have an evaluation for each node. They're going to do pattern matching on each variant. There's a lot of overlap, or not overlap, but almost like boilerplate in the processing of these things. And this is kind of part of the reason why I did the stream, because I'll be doing a lot of potentially, you know, organically growing code. And I said, rather than just doing it all by my lonesome, I might share it with, you know, anyone who could be interested in seeing an interpreter being built. So let's see, evaluating a statement. A statement for now can only be an expression. So again, we'll do this for now, but with the knowledge that as we add more variants, we're going to have to change it. So that can be a statement. And again, a statement will result in an empty value, or it won't have a value. And here we're just going to evaluate the expression, and an expression can be an integer or a call. So no, so we'll actually have to start pattern matching now. So so this will just come in as an expression, and we'll do a match on the expression. And the result of this will actually be a value. Wow. Oh my gosh. And so if our expression is an integer v, then we'll do something with it. Otherwise, we will say, again, we use our highly sophisticated error handling to say that unhandled expression. Yeah, I'm not great with this keyboard yet. I'm using a Kinesis Advantage 2. I've probably been using it for probably a few months at this point. Still mess up with a lot of the programming keys, but I'm not a smart man. So unhandled expression, yeah, that's all good. So now we need to actually add an evaluation of that, and that will just be again a regular int value I64, and that's what that will evaluate to. Value int v. Yes. So what does that look like? Lots of errors. Very nice. Excuse me. So first of all, we have to add the type. Mismatched types expected a string because of the return type, and found nothing. Oh, we have to discard the value, do we? Probably. Maybe that. And then last thing is line 37. Expected that, but found that. And here we go. All right, so yes, so we have our evaluation, but we have not run it yet. So let's try this. So value the value of our evaluation, well, it's not the actual value, it'll be the result. In fact, let's call it appropriately in that case. So evaluate our program, and then we'll output the result. And can we guess what we're going to get here? We're going to get a nice error saying that there's an unhandled expression. Nope. Because, oh yes, because we're not actually handling the errors. And this is kind of the reason why we don't want to use panics, because we do want to build in some kind of proper error handling into this into the evaluation tree. So let's go match, and if that's okay, then yeah, so we don't actually care if it's okay, we just care if it went wrong. So if we get an error here, then we want to bubble the error. Otherwise, we discard it. We discard whatever whatever came back. And do we do the same thing here? Yes, we do, I believe. Yeah. And this will change to expr. Let's try that. Didn't match anything, expected that, but got result. So on line 50, yeah, same thing up here. This is different though, yeah. And yeah, I probably prefer this syntax a little. Again, Go is my daily driver, so this notion of return early is more natural to me. And so we have our unhandled expression. So this our evaluator just does not know what to do with a call node. So let's build that in next. And what does the AST look like for that? So we have call, and we can have a function and arguments. So the first thing to do here is to evaluate all the arguments, and they will go into a vector of vals. So for arg in args, vals push arg, well, a val expression, and arg, but only if it actually gives a good value back. So we'll make sure that if it's okay, then everything is gravy. Otherwise, we do an early return. So we're evaluating all of our arguments there first before the function call gets called, and it's going to do it from a traditional left to right. And next we need to do actually evaluate a function. So now is the time where we need to actually introduce an environment into our program. So this is like I was explaining before, how the function actually has to live somewhere, and we could of course hard code a mapping of all the functions that we support, but better yet would be to actually define that mapping as the environment. So how best to do this here? Brilliant. And then we'll define what it looks like once it's actually evaluated. So we'll have a function, and we'll put it into a variable called f, and f will take a bunch of values, a vector of values, and return a value. Nice. So with that in mind, so here we have our list of values. So f will just be able to take that as is. Will f return would it be possible for f to return an error? I'm gonna say no. No, not like that. So once we have f, and f is going to look like this. So it's going to be vec of value, and it returns a value. Let me just check my crib sheet again. Double check that that's how I want to handle this. Oh no, so it will be possible for functions to fail. So for example, if we pass the wrong number of arguments, of course. So so this will be a result. And so then when we match it, it can either be okay or it can have an error. That should be a comma. And we can probably use an if let here. If let error e is equal that. No, we can't do that here because we need to actually return the value in that case. In fact, do we need to do anything here? We can probably just return that as is. Nice. Anyway, so now comes the tricky part of actually looking up print in the environment. And do we want to support first class functions now or later? Oops, sorry, that was probably a bit disgusting. No, I unmuted too soon. Anyway, let's see. So yeah, so we won't do first class functions for now, but we will handle the environment and just hard code the environment lookup for functions. Whereas later it'll probably still be similar. Anyway, back to passing the environment as a parameter. So we're going to have this hash map that we pass throughout throughout the evaluation functions, which will be our environment. So it'll map strings to values. And will it be? Yes, it'll be mutable. And there we go. There we go. And we need to initialize it up here. And I'll break this stuff up a little because no, they'll be shortened later once I actually remove the pattern matching. So that's all right for now. And next thing I want to do is build our initial hash map for the environment hash map. I'll also need to actually import the thing. So use standard collections hash map. And let's see, I want to insert a function definition. Oops. And that's going to be print. And what are we going to put in here now? And it's going to be a function that, but it's still going to have to be a value anyway. So we better add support for first class functions already. So a function in this language is going to, so we're not going to bother with too much with reflection stuff at the minute. It's just going to take arguments and oh no, it's going to be yes, that's how Rust does it. So we're just going to define f as a function that takes a list of results. Do I not need to put a box in there? Result. It takes a list of results and returns, it takes a list of values and returns both a value and, my typing is dreadful, and returns a string in the case of an error. So then we can define, let's see, print will be a value, which is a function f, and print is built in into Rust, isn't it? So and we at least don't want to override the macro. So print, what do we call it? Print underscore for now, or print prime. Print prime will take a list of values, or a vector of values, and let's see. So for now, we'll just use our own, or use Rust's built-in functionalities, so to just print directly to the console, and then it'll return. So what is a sensible return from print? So we'll just add, we'll do the million dollar, what's called the $1 million mistake again, where we add support for null. Nice. And do we want to support? So at the moment, this print function supports var args. I'm not a huge fan of var args, so eventually I will probably remove that from the language. But for now, it's fine. So next thing we want to do is, so in our expression evaluation, we'll look up the function in the environment. And how do we do that? Is it .get, I believe? And get func. Well, we'll have to do a match here, won't we? Match. And if it's a yeah, if it's actually a function, then we're all good. Oh no, so we actually want to find out if there's something there, and if there is something there, then everything is groovy. Otherwise, we want to turn that into an error. Error return format. Again, very inefficient code. Like, this shouldn't be, I think this is meant to be rendered in closure and stuff like that. But again, my first objective is to get the thing working and working right, and then I'll worry about performance and things like that. So format, what would this message be? That not found in environment, or what am I doing? Isn't defined. And then that'll be func. And now this is a generic kind of environment lookup that can be applied for any expression. Like this doesn't just apply to functions. So eventually we will be replacing that identifier. The way that function is, the function name is defined as an identifier. Eventually, a function can exist anywhere. It can be in a variable, it can be in an index, or at an index of an array, it can be in a map, any of these kind of places. So this kind of generic environment lookup will be put somewhere more appropriate, and this will just be an evaled value. But this will work for now. in fact, this is a nice shortcut to get this thing working before we have to implement that generic behavior, because there's probably a few extra moving parts for that. So now we have our item. Last thing to make sure of is if it's a function. So if let value func f, yeah, we'll just call this v. Again, top class variable naming here, really best of the best. But so first it's a v, and then we'll make sure that the v is an f, and otherwise we will return an error. And yeah, now we'll probably have to borrow this up here because we want to reuse the function name, even though this is going away later, but we'll just make them simple for now. Because the function, and otherwise we'll call it. And that should be it. You know, once we get rid of the million errors. So what are some of the obvious ones? So line 70, vals push. Yes, it probably would make sense to add the value there. Line 82, expect any num value but found a box. Ooh, yes, that would be a problem. Where is that box coming from? Oh, from each of the args. So probably want to unwrap that. Is that the issue there? Or dereference it? That looked like it ended up with more errors. Let me just double check. Still 7 errors. We'll deal with that in time. Line 102, value cannot be formatted using that. Of course it can't because it doesn't yet derive. What is the syntax here again? Yeah, that was silly of me. 6 errors. Mismatched types on line 82. Expected a value but found a struct box. Okay, that's what we were looking at earlier. Let's see. Let's try having another drink but muted this time. Success. Line 54, yes, we actually have to propagate our environment throughout all our different calls. And any other evals. Yeah. That's it, I do believe. Line 23, of course, yes, we actually have to pass the root environment. 23, that should be a reference. Do I have to pass it as a reference everywhere else as well? Quite possibly. Types differ in mutability. What's going on here? Just tell me what to do, Rust compiler. That should be toString. Is that the issue? And let's see. line 69. Expect an AST expression. So when we go through each of args, then, sorry, computer's being a little slow. When we go through each of the args, then those are in boxes, aren't they? Yes, they are in boxes. So we want to get them out of boxes. Oh, and we don't want to push the arg, we want to push the v, the value, and then finally line 76. Get a function, expected a reference, but found a string. So let's try that. Line 88 is unreachable, yes, because we handle all of the cases. And line 66, we need that to be mutable. Okay, finally. And what do we get here? Wow, oh my gosh, that is amazing. We actually printed, can you believe this, a value. We printed the value 1, and, excuse me, so these two are actually unrelated. So this is the actual printed output of the program, and this is generated from calls to print in the program, and this is the actual result of the program, which is empty. So what we need to do next is, yeah, let's just add a new line here to separate print statements. And yeah, so it's going to do a debug print. Does that make sense? We'll make it prettier later, but for the moment, in fact, we might not even make it prettier. Again, this is more about we can make it prettier by doing a match here, and changing the output depending on the value. But what I'm actually most interested in with this project is the input, the input syntax, because what I'm going to be doing with it is optimize, basically just taking a standard kind of baseline programming language implementation, just mixes most of the common features that you'd be used to from other languages such as Python, JavaScript, Rust, and just optimizes some cases, i.e., calling commands. So instead of your standard languages, which what do they do? You might have to call create a new command object, and then add your environment, add your pipes on manually, all of these kind of things. And this language is going to be optimized specifically for that use case. And all I mean by optimized there is that it's going to require fewer keystrokes to get that result. So it's going to have better handling for pipes, things like that. All stuff that Bash has, but the idea being that it does it in a slightly more consistent and a slightly more consistent way, and a way that's more familiar from other languages, such as slightly nicer handling around strings, not doing weird stuff around white space, stuff like that. At least that's the goal anyway. We'll see how well we can handle that. Yeah, and I might just take a few minutes just to rest my voice at the moment. I have my water on the ground so that it doesn't spill all over my tabletop and ruin everything. All right, then I think that was enough of a break. So yeah, so we've got this. So we've implemented integer, literals, and function calls. So next thing to do here is to implement variables, variable assignment. So yeah, let's just get started with that. So first of all, what's this going to look like? So this is actually going to be a statement, and so it's going to, for now, again, these are things that which will kind of change later, but for the moment, an assignment is assigns an expression to a variable. So and a variable just being an identifier for now. Dun dun dun. So yeah, so we can assign the right hand side to a name, and let's see what that looks like in our parser. And it's probably more or less what you'd expect. So we have so yeah, so we'll still end with a semicolon, but this time we're going to start with an identifier and have an equals and then an expression. And simple as that for the implementation, or for the parsing anyway. Let's see, so that wasn't found, so must update that. And LHS, oh, RHS is for right hand side. And then we have to pattern match this. So now we need to break down our, what was previously just a single variant for our statement enumeration will now be a thing we can match on. Whoops. And let's add this here. So this is our old statement evaluation. And next is, I probably don't need the return there, do I? Anyway, for now, we'll just skip this just to see if we can remove that return statement. Let's see, statement not found in the scope. So expected a result. There, match arms have incompatible types. Can I do this? No, because if that doesn't happen, then the other branch is the unit type. So no, we can't do that. So we'd have to do this, I believe. Yeah. No, that makes sense. Makes sense in my head now. So next thing we want to do is, yeah, expression assignment should probably be defined after expression. Expression is just simpler. Anyway, so we can assign an RHS to a name. So again, we're going to be dealing with our environment here. This time it's going to be setting it. So we're again going to be evaluating our expression, RHS, but this time if there's an OK, then we will add it to our environment. And it's as simple as that, I believe. Let's try that. Expected reference, so we need to borrow that. Unreachable, yeah, because we've matched exhaustively, and we cannot assign data, to data in an index. Index mutable is required, but it's not implemented there. So what did I do in my crib notes? There's probably a function version instead of using indexing for Rust. Yes, there is. So it's called insert. And let's try that. Expected just a regular string. Oh. And we're good. So now we have assign 1 to x. And so we print 1 and then we assign 1 to x. I wonder if that's actually working. I don't believe it is, and I have reasons for my concern, but we'll pretend it's working for now. And next thing we're going to do is print x. But yes, we'll do it like that. First, we'll see what goes wrong when we try that. And we have an invalid token at location 10. I really should change these location values to line and column references, but I'm lazy for now. Yes, so here's what's going wrong here, and this is something I found out. So it says location 9, but it's zero-based indexing, so it's actually position 10, and it's failing on the white space here. And this is because the parser generator, when you add your own, by default, the default lexer generated by this tool ignores white space, but when you start adding your own lexer rules, then it handles white space. Like it'll fail on it. It makes white space significant. So we need to. So once we add support for comments, we also need, and this is something that I alluded to earlier but didn't give any detail on. But basically, we need to add in a rule. Once we add in a rule to ignore comments, we also need to add in a rule to ignore white space. And so then when we save that, this should at least allow us to parse the full line here. And yeah, so we have an unrecognized token now. Closing paren. As that? So 24. So it's this parenthesis. Now, why would that be the case? That's interesting. So let's just scoot this over a little bit. So that can be any expression. And we don't actually support, identifiers aren't expressions yet. So let's sort that out. I feel like I'm doing something bad here, but I'm not sure why. I feel like this isn't structurally sound. Should identifiers go in with the rest of the expressions? I don't know, but we'll try it anyway. So ident name is going to be a string, and then let's see how that goes. We're not covering the case of an identity in an expression yet, so we have to now add support for evaluating variables. And this is basically, again, just going to look up the environment. Excuse me. And going to get name. And let's try that. Yeah, so when we have an identifier, we just grab it from the environment. Should be as simple as that. Func isn't defined. No, it isn't. Very well. And then line 76, what's going on here? Expected and okay. Oh no. This. Expected reference found. So I have to give it a comma here to get it from the environment, but then when it comes out of the environment, what's going on here? Expected enum value found a reference to a value. So it'll be like that regardless. Do I need to clone that to get it? Because I'm borrowing it from the map. And yeah, again, so this is one of the reasons I added clone everywhere, so that we can just kind of bypass Rust's lifetime rules by just cloning everything all the time. Very non-performant, but functional at least. So I guess that gets us over the hump. Maybe. Expected enum value found a reference to a value. So how do we get around this? Again, crib sheet. What did I do for this? This is the correct area, yeah, evaluating an expression. I actually have the same setup here. But I actually called this var, and that's probably a slightly better name. So I'm gonna change it here and just distract myself from my failure for a moment. No definition for var this time. LALRPOP line 15. That's 16, 15. Expression, var name, no different. Because that doesn't exist in the parser. All right, so now we're back to the actual problem, which is how to get this variable out of the environment. That's not in the environment, it's out of the environment, because the front's not to come off. Some v goes to OK, v clone. Hmm. Don't know what that was supposed to do, but hmm. Can I dereference it in some way? I don't think so. Yeah, a move happens. It doesn't implement copy. Hmm. Yeah, kind of stumped here. And the variable name is just a string. Maybe if I start adding some explicit types around here, I'll get some insight. Let v prime equal v, and we'll make sure that that's a value. And we'll, let's say, v prime prime will be equal to v prime clone, and we'll return v prime prime. So expected something there. Yeah, didn't want that. Expected an enum value, found this, and that was expected due to that. So if I clone a reference, I don't get a full object back. Do I not? And these all have clone derived, don't they? Yes. So let's take a look at good old Google, see what they have to say. And so Rust clone reference. I'm guessing I can't do this. Is it not? Method not found in value. Yes. Yeah. This is correct. Okay. Yeah. Yeah. Yep. Okay. That solves the mystery. So I had clone defined on all my AST methods, but not on the actual value type. Okay, there we go. So we go print 1, then we assign 1 to x, and then we print x. Nice. Whew. All right then. So next, I actually I took on a lot A lot of work for myself, didn't I? So this is going to incorporate Boolean logic and integer comparison. So let's see. Sure, let's get stuck in. Oh, and it's actually not so straightforward because we're going to have to start addressing precedence of expressions here. Okay, so what are we going here? Invalid token, yeah. So we haven't implemented less than yet. So we're going to have to do something about that. So the next thing to do, let me just double check that again. To do this, no, our test. So print x is less than 2. So we need to be able to support infix operators. Now for this, do we have enough time for this right now? Maybe, but we'll give it a try. So first thing we need to do here is because now I can't remember at what point this would make the grammar ambiguous, but basically introducing this kind of expression where it's just expression followed by an operator followed by an expression, I believe. Makes the grammar ambiguous. So let's see. So if we do it like this, RHS expression, and then we try to and we won't actually embed the operator just yet, but if we add our AST support for that, operator LHS, there's going to be an expression. RHS is also an expression. Oh, I didn't need to put that in a box, did I? Did I? I'll check in a second. No, I didn't, because it's not directly embedded. I need to put these in boxes. Otherwise, we can't define the size of the struct at runt or at compile time. Yeah, and we just add our unhandled error here for now. Oh, that's not ambiguous yet. Okay. Basically, at some point, I believe something to do with these kind of operations will cause our language to be ambiguous, but it doesn't seem to be just due to the recursion rules and things like that, and the order in which the parser generator reads these terminals. There can just be ambiguity about what order it does things in, because it doesn't take any particular approach by default. But that doesn't seem to be an issue right now, so we'll just say okay, nice one. So location 32. Again, I don't have rows and columns turned on for this, so so I just have to put everything on a single line and jump to the correct point. Location 35. Less than isn't good enough. Is this because we don't support multiple parameters yet? I don't think so. Left hand side is an expression, which is x. Right hand side is an expression, and it's failing on the less than symbol. which is an invalid token for some reason. Hmm. Hmm. So let's try out some of these things. X on its own is fine. 2 on its own is fine, but introduce an operator, and that's an invalid token. I don't believe, did I save this file? No. Okay, yeah, that makes a lot of sense. So I hadn't saved this file at all. So here we see the result of there being an ambiguity in the grammar, and I also noticed that I hadn't put these in boxes, so I would have been getting a compiler error here anyway if that was compiling or was being built. So yeah, um, uh, quite a quite a number of kind of short-sightedness there. So let's see, can we resolve this ambiguity in the grammar first? So the language itself, or the parser generator, doesn't support, like I said, it doesn't resolve ambiguities for you. So we basically have to encode that into the structure of the parser, as it were. Um, so we do that by splitting up expression. I'm just going to do, some of these implementations would split these things up into lots of like properly named substructured stuff. So for example, we could have top level as expressions, and then we can have if you see these simple calculator examples, we'll have expressions. Then we have rules for operators, which are factors, or they're kind of multiplications and divisions. Then you can have terms, which are plus and minus, and then you have, it's kind of all these different layers. I'm just going to keep it simple for now and say that we have expressions and expression primed. And one thing you'll notice here is, even though I'll be encoding the different kind of layers of precedence rules explicitly here, by dividing expression into kind of higher precedence rules and lower precedence rules in expression primed, they're still both going to generate expressions, the same expression, generate values of the same expression type, because even though they're handled at different layers, that's not, that's information that's actually going to automatically be included by the nature of nesting of the AST. So it's not something that we need to create new types to handle. We could. I just wouldn't see the need. Like we'll have different variants inside expression, and that'll be enough to encode that precedence for me. So let's see here. So the first thing for handling this ambiguity is to say that the hand side has to be an expression. So this is kind of the area of recursion. So it's saying this is the kind of higher precedence side, I believe, and this is the lower precedence side, which is going to be expression primes. So there might be something here, or there might not. Yeah, I don't know how to explain this really, but this is what we do to resolve the ambiguity. And we also need to change these guys. Oh no, we don't actually. Oh no, yes, we do have a reference to expression here, and that has to be changed to expression prime. And does that work? Can that be an expression? Let me see. No, that would probably have to be an actual expression. Let's see. Yeah. Okay. So we seem to have handled that all right. So what I'll do next is I will add support for a new operator. I've come in over time, so I'd only planned to do 2 hours of this, but you know, another little bit won't hurt. And so we'll add operator support. So we know that, so at the moment we've hard coded the operator to be the less than operation. So next thing we need to do is we have the left hand side and the right hand side, and we need to make sure that at the moment we're only supporting integers with this. So we need to match LHS and RHS to be value ints. And that's going to be RHS, and it's going to be a less than a value always. So LHS is less than RHS, and otherwise we get an error that values aren't compatible. Invalid types. And again, not very well handled errors here for now, but it does the job. RHS, and there we go. No, we don't go. So let's see, line 82. And I'll scoot this over a bit to see this a bit better. And line 82 expected a box. Yes, this is something that I need to address with the rest of the implementation, but probably not right now, actually. Yeah. So can we do that to get them out of the box? 81 and 82 expected an expression. Oh no, so we need to evaluate the left hand side and right hand side first. So can we be smart about this? By trying to evaluate these one after another. And let's see. LHS, RHS, and V and vals, V, yeah, we want to, so that's a list of expressions. And they're boxed expressions, so we need to get them out of the boxes. Eval the expression and push the V. Can probably just do it like that. And DI that. Push values, yes, I believe so. And then can we do this? Let LHS, RHS. I should be naming things better, but however. Pattern cannot match with input type. Yes, that makes sense. But can I do a drain or something to convert it to a slice? Rust vectors. So drain. What does drain do? It sounds like something that will be what I'd want. Not getting too much info from the docs, but maybe Rust just does what I want. Supplied 0 arguments. Maybe if I change it to, so is clear the same as drain? No. Drain filter, no. I could potentially do it to as slice. Probably running into a lot of potential runtime issues here, but again, working first and then we'll tidy it up. Expected value wanted a bool. Okay, yeah, we're where we want to be now. So this will be value bool, and that's a very long line. So we'll do like this for the moment. And we don't have that type of a value yet, so we'll add it, bool b and bool and refutable pattern. Okay, yes, because it doesn't cover any other patterns. That was a little cheeky of me, I'll admit. But I'm kind of wanting to just get it running soon. Okay, we'll get rid of the unreachable pattern for the moment anyway, because that's not going to be matched. Yeah, we'll go if let for the moment. That's better for avoiding errors anyway, and we can have a little to-do error. and here for the moment. So this will be if it's matched, and this is basically just a dev error, because realistically, we as developers will be fairly confident that, you know, like we've created this this array of two values. I find this to be an interesting thought that yeah, again, it just shows the limits of type systems. And yeah, you can probably solve this this stuff with dependent types, but it's a lot of overhead to handle it. But basic idea is, I know that I've created this this vector with two elements. I've iterated it, and for each element, I will put one element into the values array. And once I get down here, you know, it's not formally proven, but you can, you know, you with a high degree of probability, you know, assuming that this works as expected, you know, this should it should be impossible for this not to match. But the compiler doesn't know this, so you know, we need to be able to handle that case as well. So by this time, like if that didn't match, it basically just kind of comes down to a flaw in our assumptions of how our program is even running. So so we'll just add a dev error here for the moment to indicate to us that something went horribly wrong. So dev error unexpected slice size. And we're good. Nice. We have Booleans working, and comparisons in one direction. So yeah, so nice. Didn't get quite as much done in this session as I was expecting, but it's a lot cleaner than the code that I did have on my crib sheet. And from here, I will be yeah, just fleshing it out more and more. Once I have this running, if statements are very straightforward, and we've print done, and then we'll also need to add support for strings. So that's 3 more features to get, and we'll need to handle if else's or the else branches at some point. I haven't looked into the again, that's another area of dangling else can introduce ambiguities into your grammar. So I'm not quite I haven't looked into how to resolve that, but not too many features left to start having full support for this snippet anyway. Nice. Anyway, thanks to anyone who's watching, and yeah, I'll see everyone later.